On the 8th day of Christmas, my techies gave to me 8 machines learning, 7 algorithms, 6 databases, 5 passing builds, 4 service calls, 3 git commits, 2 unit tests, and a story, and some pairing. Yeah.
You know, Christmas was made for the children.
All right, I'm here with Nicola. Can you tell me about yourself?
Yes, my name is Nicola. I'm a software developer at ThoughtWorks. I love greyhounds, and my favorite color is green, and I like pizza.
love the
I
song.
love pizza.
Right. All right, so today we're going to be talking about machine learning, and we have an expert right here. So tell me about your experience with machine learning.
Yeah, sure. So I'm currently studying different aspects of machine learning through Georgia Tech's computer science program, and I think I have enough information to give a cursory overview.
All right, we're excited. All right, so what do you want to tell us about machine learning?
Yeah, sure. So you can think of machine learning falling into 2 broad categories. One is supervised and one is unsupervised. And with supervised learning, you have some input, which is a large set of data, and the output is something that you are trying to get answers for. So with the input, let's say you have pictures of cats. With each picture that you show the computer, you will give it a label like cat, dog, monkey, whatever. And then once you're done with this training process, you can query or ask it to make predictions based on pictures that you feed it, and then it'll give you its predictions. So this is supervised because you're giving it constant feedback, like this is a cat, this is a dog.
Right.
The other style is completely unsupervised and doesn't involve any human interaction, and you give it some information and it crunches on this data, and then it produces some results.
Gotcha.
So some of the outputs for the first type are classifications. Let's say you have a whole large series of emails that you feed it, and you classify each one of these as spam or not spam. It will be able to classify. The idea is it will be able to classify some of this in the future and label email spam
with no human intervention.
Afterwards, right? So you train it with human intervention.
Oh, right.
So you train it with human intervention. You say spam, not spam.
Right.
Afterwards, it knows what to do. You could see this in play in like email filters like Google and whatnot.
Right.
Yeah.
Gotcha.
So unsupervised would be you give it the stuff, it crunches, and then it gives you some answer.
Right.
And the nice thing about that is maybe it'll discover some patterns that you didn't know existed in your data, which is great. Generally, so this is like the big goal. Generally, you have to do a lot of work to reduce how much data you have to something that the computer can operate on. And one of the things that you can also use machine learning to do this, it's called dimensionality reduction, which is to take data that has many different features and to reduce it down to a few. And so this is like removing things from the data that are highly correlated with other features in the data. So maybe an example would be, here we pause while I think for 10 minutes to come up with one.
So what about the example of you're trying to predict, wow, it is hard to think about.
Yeah. So
What about Pac-Man?
Pac-Man. I was going to say something that I have a little bit more experience with is portfolio data, like with stocks.
Okay, yeah.
So an individual stock will have something like a price, the open that it started at the day, the close, the five-day rolling average. It'll have price and earnings. It has a ton of information,
Right.
and all of this stuff is not. It's correlated, right? It's not all completely independent of itself. It's all correlated. Like generally, if the price of the stock is moving upwards, the price earnings ratio and all these other things move in the same direction.
Right.
And so maybe you don't need 6 gigabytes of information about a stock forever. You just need like less of that.
Right.
And by trimming down how many things that you are training on, you can work quicker and as a result like tweak your algorithms more and get to a result faster.
Right. Okay, so give me that phrase again.
Dimensionality reduction.
Dimensionality reduction. So basically I say, I have all this data, but you should only care about this.
So I have all these different facets to this type of data, and I want to reduce how many things I'm looking at.
Right.
So if I'm trying to predict whether or not this equity will rise in price, I can look at all of these different things that I measure for that one piece of data, for that one stock, and I will say, actually, I don't need all of these different metrics. I'm only going to focus on the price, and then maybe what the price was yesterday. So like 2 instead of all of this information.
Does that make it more performant?
It makes your scope narrower, and you're saying, I'm going to put the blinders on and not look at everything and just focus on maybe these 2 things, and these 2 things I believe will give me good results.
Gotcha.
So the devil's in the details, right? Like everybody loves machine learning, but the way that you actually get results is by tweaking all of these parameters and coming up with the right secret sauce for whatever you're working on.
Okay, so what I'm hearing is machine learning in a nutshell is basically you have this data. And through some form, whether it's supervised learning or unsupervised learning, you want your computer or your algorithms to generate some kind of answer, some kind of patterns, some kind of analysis. How is that different from big data, and what's the difference between machine learning and AI? All these buzzwords.
Yeah, good question. So machine learning falls broadly underneath the category of AI, artificial intelligence, and maybe even more broadly under the category of data science. And under data science, you'll have things like machine learning, computational statistics, big data, and all these things kind of like blend together. So like big data will come from a place where you have just lots of information. So a common source of this is maybe, I don't know, a bank has lots of logs from their servers, like gigabytes and gigabytes of these logs, and there's a lot of information in there, but there's also a lot of noise. So perhaps you could use a machine learning algorithm to pare down what we are looking at. Maybe some sort of unsupervised algorithm can look through this data and find anomalies. Like, oh, this thing is kind of interesting. Like, this is unexpected. Perhaps this is fraud, or who knows what. So it could like narrow down the sort of things that we look at. So you don't have 10 gigabytes. You only have maybe 1. But it's still a lot.
Okay, cool. And I guess one last question. A lot of people come to me and they're like, oh, computers are too smart. They're going to take over the world. What are we going to do when Terminator happens? How do you feel about that?
Yeah, we can worry about that, but later. Right now, I don't think it's something that we should be worrying about right now. The algorithms, although they are learning and they are smart, these are like, it's not the smart and the learning that me and you think about. They're actually really, really dumb, and they need a lot of hand-holding and a lot of tweaking, and most of the time they just don't work.
Okay. Yeah, we know about that.
Yeah.
All right, anything else you want to add?
That's all.
All right, thank you so much.
Thanks for having me.
Yay. Day 8.